Hi everyone, Mr. King here. I'm going to do some quick review of some of the problems we've been working on the last few days, solving absolute value inequalities. One of the keys to solving absolute value inequalities is to never ever forget something called the double switcheroo, right there. So let's take a look at this first absolute value inequality. I think most of you worked this the other day, but here's a quick overview. So we want to isolate the absolute value first. That's the key. Mrs. Donahue talked about that quite a bit yesterday or the day before, whichever day it was, doesn't matter. Alright, so those guys knock each other out and we're left with, and I should have moved these arrows, I guess I'm writing a little too big, but we get absolute value of x is less than or equal to 6 minus 1, which is 5. This is the absolute value equation we want to solve because this one's easy. This is as basic as it can get. So here's where our arrows should be. And now we're going to write two separate inequalities without the absolute value. The first one we write exactly what we see without the absolute value. And that one's solved. And then for the other one we do the double switcheroo. We're going to say x is greater than or equal to a negative 6. So we switched the inequality sign and we switched the sign of the number on the right side. This inequality is solved. And let's put this on the graph now. This is either an and or an or inequality. Okay, we don't need that line. Let's see if I can, there we go. So let's see, x less than or equal to 5. I'm going to put 5 right over here. Well, we don't want to do that. We need a pen. Let me get the pen. We're going to put a 5 right there. And we've got to be less than that. So that's going to be going this way. And then there's a negative 6 that we need, and I'm going to put the negative 6 over here. Remember, we don't really care what the increment distance is. We just need these two numbers, 5 and negative 6. And if we are greater than or equal to negative 6, we need to go this way. So we're going to be connecting here, like this. I like the way Mrs. Donahue pops up the circles or the dots. Now, do I have this correct? Take a moment to think about it. Well, you probably realize that because it says less than or equal to and greater than or equal to over here, these need to be filled in dots on the ends, not circles. That means we can have equality at those values. Now, is this an and or an or inequality? The solution's in between, so this is an and inequality, so we can put the word and to join our two inequalities. Let's move on to another example now. We're going to tackle number 4 now, so I skipped a few obviously. And again, the first step is to isolate the absolute value, so I'm going to subtract, let's get a pen here, I'm going to subtract negative, we're going to subtract negative 20 here. I'm having a little bit of trouble here with the technology. Come on, there we go. Subtract negative 20. And that gives us absolute value of 5x less than or equal to 35 minus 20 is 15. Again, my arrows really aren't in the right spot. We're going to need to do one more. Well, actually, I take that back. They are perfectly placed. We can now write our two separate inequalities that don't have absolute values. So we are going to write 5x less than or equal to 15, and we're going to write 5x, and now we do the double switcheroo, greater than or equal to negative 15, like that. And then we can solve for x. We'll divide by 5 on each side here. That gives us x less than or equal to 3, and we'll divide by 5 over on this side, and we get x is greater than or equal to negative 3. And again, we're going to want to put this on the number line. So let's see. We need to put circles or dots on 3 and negative 3. Now this says less than or equal to, and this says greater than or equal to, which means dots. So I'm going to put negative 3 over here, and I'm going to put positive 3 over here, and put a dot on negative 3, and we'll put a dot on positive 3. And let's see, we're less than or equal to to positive 3. So we've got to go this way. And we're greater than or equal to negative 3. So we've got to go this way. This is also an and inequality. And that solves that one. Now number 6 looks similar in difficulty to the previous one. Again, we're going to isolate the absolute value, so that means we need to subtract 4 from each side here. And that leaves us with absolute value of 5 minus x is less than or equal to 9 minus 4, which is 5. And then we'll go ahead and write our two inequalities that don't have the absolute values. So that will give us a 5 minus x is less than or equal to 5, and a 5 minus x is greater than or equal to negative 5, the double switcheroo on that one. And now let's go ahead and solve for x. We've got a minus sign in front of the x, don't we? Well, I'm going to do this one by subtracting 5 from each side. This will isolate the negative x. Remember that negative sign when we bring this down. This is a negative x. Less than or equal to 5 minus 5 is 0. This is perfectly okay. There's nothing wrong with this inequality. Now at this stage, we want a positive x in our solution. So we are going to change every single sign to get x. Change every sign in this circumstance. So that means negative x goes to x, less than or equal to switches to greater than or equal to, and the 0 can't switch, so it's still 0. And that's that part of the solution. We're going to do a similar thing over here. We're going to take 5 from each side, and that leaves us with a negative x greater than or equal to negative 5 into negative 5 is negative 10. Again, we have to change every sign, and so this goes to x from negative x, less than or equal to, and negative 10 goes to 10. So we switched every sign. Because of that minus sign there, we had to do that. And so now let's go take a look at the number line for this one, and we'll see if this is an or an and inequality. So we need we need a circle or a dot on 0, and I'm going to put 0 right here. And the same goes for 10. I'll put 10 right here. Now, less than or equal to and greater than or equal to, so we need dots. So we put our dots on like that. And let's see, if we're greater than 0, we got to go this way, and if we're less than 10, we got to go this way. And there's our solution. This is clearly an and inequality. I think every example I've done in this particular tutorial is an and inequality, and it just turned out that way. Finally, let's take a look at this one. Absolute value of 3x plus 2 is less than 11. Well, the first step is to isolate this absolute value. So let's do that. I'm going to isolate the absolute value. To do that, we need to take 2 from each side. And that gives us absolute value of 3x plus 2 is less than 9. Now we can form our two separate inequalities. So 3x plus 2 is less than 9, and 3x plus 2 is greater than negative 9. There we performed the double switcheroo. Oh, it's 750. Now we're going to subtract 2 over here to isolate 3x. So we get 3x is less than 7. And then we'll divide each side by 3. And so we get x is less than 7/3, which is about 2.3. 2.3 bar is a decimal, actually. And I did that because we're going to want to know where to put this on the number line. Place that looks reasonable. Okay, now let's go to 3x plus 2 is greater than negative 9. We're going to subtract 2. and we've isolated the 3x. 3x is greater than negative 9 plus negative 2 is negative 11. And we'll divide each side by 3, and we'll get x is greater than negative 11 thirds. Negative 11 thirds is, well, 3 times 4 is 12, so 3 goes in 3 times. 3 times 3 is 9, but there's 2 thirds left over. And that's about negative 3.7 as a decimal. It's approximately that. So now we have a good idea where to put some numbers on our number line so we can graph the solution. So let's see, 2.3, negative 3.7. Well, if we make this negative 3, let's make negative 3.7 right there. We'll put it there. Now notice this inequality has a greater than. So this should be an open circle. No dot on this one. So that value, we want to show it. That value is negative 3 and 2/3. I'm using the exact value right here. And then we need this 2.3, the 7/3, and I'm going to put that one over on this end. So I'm just going to say this is 2. And if that's 2, then 2.3 is clearly a little further over, isn't it? So I'm going to put that over about here. And let's put our circle on there because this is less than, so this is also a circle. Now we have to figure out which way we're going to shade. I changed the order this time slightly. I put down the 2 circles first. Well, if we start over here, we have to be less than 7/3. That's less than 2.3, and that 2.3, or 2 1/3, is over here. That's the same as 7/3, by the way. We need to be less than that, so we need to shade this way. And then if we go over to this side, we've got x greater than negative 3.7, or negative 3 2/3, so we need to shade this way. And once again, we see that we have an and inequality. So that's my tutorials on video for this morning, and I hope that was helpful to you guys in your self-checking of your work and asking questions in class today. So we can all discuss this more live, real people to real people, in real time if we need to. Again, I hope that helped. This is King and Donahue Algebra, over and out.